Professor Bumbleweed here. Massive ships weigh absurd amounts, yet they sit on water like smug ducks. This quick few-minute tour explains how. It keeps things lively while actually teaching buoyancy, displacement, and density without melting brains. Picture the ocean as a million invisible hands. Each hand presses from every direction. More depth, more pressure. The hull feels stronger push underneath than above, so the ship gets lifted. Physics calls it buoyant force. Buoyancy is not magic. It is bookkeeping. The ship sinks until it displaces enough water that the water's weight matches the ship's weight. Match equals float. No match equals sinking, plus very wet regret for everyone. Steel is denser than water, yes. Congratulations, you noticed. But ships contain huge volumes of air. What matters is average density, ship mass divided by the volume under the waterline. Keep that average below waters, and it floats. Think of a ship as a bowl turned upside down. The bowl traps space, forcing the water to move away. More moved water means more buoyant push. The steel matters, but the empty space inside does the heavy lifting. Look at the underwater cross-section. Every extra centimeter down adds a slice of volume. More volume displaced means more buoyant force. The ship stops descending exactly when buoyancy equals weight, like a stubborn elevator that finally levels. Add containers, fuel, and people with snacks. The ship's weight rises. To match that weight, it displaces more water, so it sits deeper. Overload it, and the deck kisses the sea, which is romantic but disastrous. When a ship leans, the underwater shape changes, so the center of buoyancy slides sideways. That sideways shift can push the ship upright like a weighted toy. A bad design slides the wrong way and starts a very expensive nap. Ballast is the ship's hidden gym weights. Adding heavy mass low in the hull drops the center of gravity, making tipping harder. Tanks shift water ballast around to keep level as cargo changes. Yes, even ships need posture control. Real ships also plan for leaks. Watertight compartments limit how much water floods in, so the ship's average density and stability stay manageable. Damage control buys time. The ocean still tries, but it meets doors inside. Remember the three-part scam. Pressure increases with depth, giving buoyant force. The ship sinks until displaced water weighs the same as the ship, and the hull spreads mass across huge volume, so average density stays low. Add ballast, stay stable. If this little floaty mystery feels clearer, tap the like button. It tells the algorithm that science sarcasm deserves food. If it feels unclear, also tap like. Confusion still counts as engagement, and I respect honesty. Drop topics in the comments. Without them, the animators stare at a blank timeline, and I stand here doing my best mime impression. Leave a suggestion, and this channel stays delightfully noisy. Until next time, then.